Hello, everyone. In this chapter, we're going to learn about the association between two variables graphically. The statistical tool for studying such associations is called a scatterplot, and we'll learn how to handle those both manually as well as using technology. Basically, the two types of variables that we would like to study in a statistical setting is what we refer to as the explanatory and response variables. We would like to see if a change in one variable is associated with a change in another variable. And basically, what we're going to do is we're going to graph such change as long as it's numerically represented using the familiar horizontal and vertical axes. Now notice in algebra we always refer to these as x and y, right? Now in a statistics class they take on different letters based on a given situation, right? So but nevertheless we always reserve the horizontal axes for the explanatory variable and the vertical axis for the response variable. And that helps us kind of always be consistent in respect to what we mean by an increasing type of association or a decreasing type of association, etc. We also refer to the explanatory variable as the independent variable and the response variable as dependent, because we are hoping to show that the change in the explanatory variable is the one that results in change in the response variable. So the response variable is dependent on the explanatory variable. All right, in the sense of a change in it, of course, is what we mean. Here we'll take a look at a few examples. We want to identify the explanatory and the response variables. So for example, in the first one we have let W be the number of minutes some shirts are washed, and let P be the percentage of stains that are removed. Here, of course, we're going to be assuming that the number of minutes that a shirt gets washed is going to have some effect on the percentage of stains that are removed. So here are, if we're going to do the graph, we're going to represent the number of minutes of washing horizontally, because that'll be our explanatory variable, and we'll represent the percentage of stains that are removed vertically if we're going to have the numbers represented on a graph. And so of course, again, W will be our explanatory variable and P will be our response variable. Note that it wouldn't make much sense the other way around, like to see how the percentage of stains removed affects the number of minutes that the shirts are washed. So these kinds of associations usually make sense only in one direction, with one variable playing the explanatory role and one variable playing the response role. For our second example, we have P is the percentage of people who think that a man of height h inches is attractive, right? So here, if we're going to be representing this situation graphically, we would put the percentage of people who think that a man of height h is attractive. Notice how putting the percentage on the horizontal line wouldn't make any sense, right? because it's not the percentage of people who think at a man of height H is attractive that makes the man of height H attractive, but the other way around, right? So we're assuming it's the height that is going to be the explanatory variable, and the attractiveness or the percentage of people who find the person attractive will be the response variable. All right. And again, it would not make sense to look at it the other way around, right? Like seeing the percentage of people who think that a man of height H is attractive affecting the height of the individual, right? So basically, only in one setting does this make sense, with H being the explanatory variable and P being the response variable. Next, we have a car traveling at speed S in miles per hour on a dry asphalt road, and the brakes are suddenly applied, and D is the stopping distance. Which do you think affects which, right? Well, normally we know that it's the speed that affects the stopping distance, right? So if we're going to draw this situation on a graph, we will plot the speed values on the horizontal axis and the corresponding stopping distance values on the vertical axis, right? So S would be the explanatory variable and D would be the response variable, right? So notice it wouldn't make sense to think of it the other way, right? The stopping distance does not affect speed, right? So again, this only makes sense in one type of setup. It's all common sense. If you've noticed in statistics, what really needs to be active is your common sense. It's not as exact as, say, algebra, right, where things are very cut and dry. In this, you need to be very fluid, very flexible, and consider all situations from a rational, common sense type of mindset. All right, so in this next example, we want to interpret ordered pairs associated with one of these associations, right? So here we have W representing the weight in pounds of a person and H the person's height in inches. What does the ordered pair 66, 142 mean in this situation? Well, clearly it does. 142 here can't be the height, right? We don't have any human beings that are 142 inches, right? So this must be the height here, and this must be the weight. So to interpret this ordered pair, we would just say this ordered pair is telling us that a person that is 66 inches in height weighs 142 pounds. Let's look at the next one. Let C be the amount of caffeine a person ingests daily in milligrams, and let S be the number of hours that the person sleeps per night, right? What does this ordered pair represent in this situation, right? Well, obviously 300 hours cannot be the amount of time that the person sleeps, right? So this can't be the hours, this must be the milligrams. So, and this 7 must be the hours. So this means that basically a person consuming 300 milligrams of caffeine got 7 hours of sleep. If you recall from algebra, we had linear equations, and when we put them in slope-intercept form, we had y equals mx plus b, right? That was called the slope-intercept form. Here m is the slope and b is the y value of the y-intercept, the y-coordinate of the y-intercept. And of course we graph these using axes, where the horizontal axis was called x and the vertical was called y, right? And if you also recall, we made tables of values, right? We put x first and then y, and we made a table, right? For example, let's say we had y equals 2x plus 3, right? We would say, okay, let's let x be 0, and then we would plug in 0 here, so we get 2 times 0 is 0 plus 3 is 3, so the y value will be 3, for example. Or we could let x be 1, and the y value will be 2 times 1, which is 2 plus 3, which is 5. So we're going to be using the same kind of strategy, but depending on the particular problem, we may not be using the letters x and y. So, but what I will always do for you is I will show you the xy model, and then we'll bring in the new letters and we'll put them up according to the same kind of order, okay? That'll be the easiest way to handle that scenario. So again, we'll put the explanatory variable on the left, the response variable on the right. Graphically, of course, we put the explanatory variable horizontally, the response variable vertically. All right, here's an example involving Super Bowl ticket prices, and the mean ticket prices for Super Bowl are shown in table for various years, right? So basically, we are going to be setting up our table with P being the mean ticket price and N being the Super Bowl number, right? So this is a Super Bowl number 1, 5, 10, etc. Notice that here Super Bowl number is going to play the role of our explanatory variable, and the mean ticket price will be our response variable. So as you recall, we always set up the explanatory variable using the horizontal axis, so this will be N, and the ticket price P will be represented on the vertical axis, right? So for this data, we're going to construct the scatter plot. We're going to find the Super Bowl that basically corresponded to the highest mean ticket price, right? And what the price was, and then we're going to describe any patterns that we see. The scatter plot is a very familiar plot to us. We've already seen it in the form of time series plot, except in a time series plot, the dots are connected with little line segments. In a scatter plot, they're not. So it's not really anything new. So for the scatter plot, we go ahead and, draw our axes. Again, remember that N, the Super Bowl number, is going to be represented on the horizontal axis, and the corresponding ticket prices will be represented using the vertical axis. So we notice that for these numbers, multiples of 5 should do pretty well, right? So we break up the line, the horizontal part of our graph, in increments of 5 like this. And for the mean ticket price, however, that's pretty extreme, right? We need to make sure that we cover anything from 12 all the way to 1500. So this growth seems to be really, really exponential here. So, and you can see that exponential pattern right here, see? So there is an association here, but it certainly is not what we call linear. Linear would be if the dots kind of lined up nicely in the form of a straight line. So this means that the jump from one year to the next is really, really significant, okay, and large. So so basically we mark our dots. We just put our dots according to the data that's given, and there we have the scatter plot, right? So again, there is an association here, and it's a function that we will study later actually in the term. it's an exponential. If you were to fit a curve to this data, it wouldn't be a line, it would be a curve that looks like this. Look at my tracing that. That would be an exponential curve, right? That's always the case when a type of growth is extremely fast, okay? So in general, is there a pattern? And no doubt, the mean ticket prices are what? Are increasing every year. Notice this is the same kind of graph we saw before in the time series situation that we plotted. And these are going to be connected in a time series plot, but not in a scatter plot. The thing with time series plots were that the horizontal axis always represented what? Time. That is not the case. We don't have that restriction with scatter plots. The horizontal axis could stand for any kind of data we like. Of course, one of the questions we were supposed to answer is which Super Bowl represented the largest mean ticket price. Well, of course, that would be this one right here, right? Represented there. So that would be Super Bowl 48. And the mean ticket price was $1,500, which is quite out there. So now we come to the notion of positive and negative association. Basically, if the values of the response variable increase as the values of the explanatory variable increases, right? So we get a trend that's upward like this, because as these values increase, so are what? So are the response values, right? When that happens, we say these two quantities are positively associated. When the opposite happens, meaning as the explanatory variables increase, notice what's happening to the response variable amounts. They're going down, right? So in this situation, we say that these two quantities are negatively associated, or we also say negatively correlated. And in the previous case, we can also say they're positively correlated. So correlation or association are pretty much interchangeable words in this scenario. All right, so a little bit more practice with ordered pairs. Look at the first one here. Let n be the number in millions of American adults who practice yoga T years since 2010. In 2013, 24 million American adults practiced yoga. Express this as an ordered pair. So first thing we need to do is we need to come up with the explanation for which one is the explanatory variable and which one is the response variable. And as you would guess, we want the year since 2010 to be the explanatory variable and the number of adults who practice yoga to be the response variable, right? So notice that in your ordered pair, this is a very, very common error. Students put 2013, 24. So again, we don't want to do this. This is incorrect, but it is common, so I'm showing you. What you want to do is you want to listen to what they want to go in here, and that is what? The number of years since 2010. So 2013, T is going to be 2013 minus 2010. That'll give us the number of years, and that'll be 3. So the ordered pair you want to write is 3, 24, like that. So be careful and try to understand what T is representing. Here, it's not the year. It's the number of years since what we call a reference year, which in this case is 2010. In the next example, G stands for the number of guns found among airline passengers at U.S. airports in the year that is T years since 2000, right? So that means the first variable here doesn't represent the year It represents the number of years since 2000, right? So what does this ordered pair mean? And remember, this one is the number of guns, right? So this means in this year, the year associating with this t value, so that would be 2000 plus 14, right? Equals 2014. For those of you who may be more algebraically inclined, remember that we have 14, which is the t value, equals 2000, or actually what year minus 2000, and then we add 2000 to both sides, we get x equals 2014. All right, so what this ordered pair represents is the fact that in 2014, so in 2014, 2,122 guns were found among U.S. airline passengers. Scary thought, right? But it's true. I think they got this data from the government. So basically, you have to really learn how to interpret these ordered pairs for any of this stuff to make sense to you. This is very fundamental stuff, but it's really important, okay? So two things. First of all, determining what makes sense to be the explanatory variable and what makes sense to be the response variable. And then, what do the ordered pairs of this kind? It's always explanatory, comma, response, right? What do they mean and what do they represent? All right, great. All right, so here's one more example for us. Constructing a scatter plot and analyzing the association. Atlantic City gambling revenues are shown in the table below. So we can see in 2008, $4.7 billion was the revenue. In 2009, $4 billion, etc. If you notice, there seems to be a downward trend, correct? We're going to be doing two things. We're going to construct a scatter plot, and we're going to determine whether the association is positive, negative, or neither. All right, before we plot our scatter plot, notice that usually we're not going to want to work with numbers this big for our plot, right? So what we'll do is we'll pick a reference here, such as 2005, and we'll let t represent the number of years since that reference year, right? So in this case, notice 2008 minus 2005 will give us 3. So that will be the number that we'll use for t. And 2009 minus 2005 is 4, etc., right? So that's how we get these values here in the t column, right? And R, of course, the revenue doesn't change, right? We're just trying to make easier, pick easier points to do our plot for, right? So now what we'll do is, I mean, of course we can do this by hand, right? And we've done, we've seen that before in the previous example. Let me show you. It looks something like this, right? So what I would like to do is I'd like to show you how to handle this on StatCrunch now. So we'll go ahead and launch that. Okay, so here we have StatCrunch, and we're just going to start typing in the first column. So we have 3. Easiest thing is just to type the number and hit the down arrow to go to the next field. So we have 4, 5, 6, 7, 8, and then in the next column we're going to have 4.7, 4.0, 3.6, 3.3, 3.0, which is going to convert to 3, and then 2.9. All right. So now also notice that, what we can do in StatCrunch, which is quite handy, is we can actually change these variable names to what we like. So here we'll use T and R, like so. So now we're going to go to graph and then Scatterplot. And for the X variable, that means basically for the explanatory variable, we're going to pick T. For the Y variable, which is the classic variable for the response variable, we're going to use R. And that should be all the information you need. You go ahead and compute. There you have it. Okay, so it does a beautiful job, right? Now notice the dots here, they're pretty large because if you go back to the settings, you can change that, the point size, right? Now we didn't draw lines here because we're not doing a time series plot, but if you wanted to, you could have it draw lines as well. So you would just hold the control button on a PC or the command button on a Mac and highlight both of them and compute, so you would get that. But in this case, we just want to scatter plot, so we will go ahead and deselect the line. We'll just pick the points. All right, just like that. So very easy using technology. All right, so again, if we take a look here, it does look like the two variables are associated, and here we would say there's a negative association, because notice as the explanatory variable increases, the response variable decreases, right, in value. So the T values get larger, the R values get smaller. So we say as T values increase, the R values decrease. When that happens, we say there's a negative association. Now let's go ahead and take a look at a few problems you may encounter on the homework set. All right, so in this example, we're looking at D being the total number of CDs in thousands that a hip-hop group sells at C concerts per year. A hip-hop group sells a total of 47.1 thousand CDs at 91 concerts in a given year. Describe the situation with an ordered pair. Which variable should be described by the horizontal axis of a coordinate system, and which one should be the vertical axis? Now, as you can see, it would make sense for the number of concerts being the explanatory variable, because the more concerts, the more CDs they should sell, right? So we'll go ahead and set it up that way. In other words, we're going to be interested in ordered pairs of the form C, comma, D. Remember what C stands for, the number of concerts per year, and D is the total number of CDs sold. So we're going to represent this particular scenario, the fact that 47.1 thousand CDs were sold at 91 concerts, using an ordered pair as such. So we'll go ahead and type it in. So we're going to have C is 91 concerts, comma, 47.1 thousand CDs were sold. So we will go ahead and put that in. Excuse me. Here we go. We had an alarm going off here. Okay, so 47.1 we'll go ahead and close that, and that should take care of that part for us. All right. So the variable d, of course, remember, because c is the explanatory and d is the response, of course, we're going to have the explanatory horizontally. So horizontal axis is going to be represented by c, and the vertical axis will be represented by d, right? So the variable d should be described by the, let's see what they want us to. Notice d, of course, will be the vertical axis, and c should be the horizontal axis. Okay? And that's all there is to that question. All right. All right, so here we have P, which represents the number of ounces of a new protein shake a weightlifter drinks daily for 6 months, and N is the number of times the weightlifter can bench press 200 pounds after those 6 months. So what does the ordered pair 12, 5 mean in this situation? So obviously we're thinking that the number of ounces of protein shakes is the one that's going to have some influence or affect, well, I should say effect. If you want to use a verb, you would say affect, or has an effect on the number of times that the weightlifter can bench press 200 pounds after those 6 months. So the number 12, 5. So in other words, the ordered pairs of interest are going to have the form P, comma, N, right? So that means when you're looking at the ordered pair 12, 5, the 12 refers to P, and N refers to 5, right? So the way select the choice below and fill in the answer boxes to complete your choice. So we know that 12 ounces of the protein shake per day should result in the weightlifter being able to bench press a 200-pound weight 5 times after those 6 months, right? So we can fill it into here. The weightlifter can bench press, so this first one is out. That's not the way we want it to be phrased. The weightlifter can, all right, so the weightlifter can bench press 200 pounds. How many times? This is the number of times, right? So 5 times. Let's see if my pen is not active. After drinking 12 ounces of the protein shake every day for 6 months, right? So so 5 and 12 should do it for us. Let's go ahead and actually try. So we'll put 5 here. And 12. And we'll check it. Okay. Now, why did we know that we should not go with this, right? Because of the kind of information that's given, right? We know that the 200-pound weight is going to be lifted a certain number of times, right? And be very careful with the subtle differences between these 3 sentences, and think about why it is that you need to use this particular phrasing and not the others. It's these subtle points that really make you strong in this class. All right, so here we have P, which is the percentage of the population who believe travel websites do a good job of presenting travel choices at T years since 2010, right? So what does the ordered pair negative 416 mean? Now remember, in this case, you would think that the ordered pairs of interest would be of the form T years since 2010, and then comma P being the percentage of the population who believe the sites do a good job, right? So the interesting thing is, if you want negative 4 years from 2010, you're not going to add 4 to 2010. You're going to what? You're going to subtract it, right? So in this case, negative 4 will represent the year 2006. So basically, we take 2010 and subtract 4 from it. Remember, if that were 4, we would have added 4 to 2010. But since it's negative 4, we go ahead and subtract it. So we get 2006. And the 16 is the percentage of the population who believe they travel sites do a good job. So let's go ahead and see how we would type that in. So we know that in here we need to put 2006. The percentage of the population who believe travel websites do a good job of presenting travel choices was 16%. Like so. Okay? So be careful with the situations where that's negative. You're not going to want to add that to the reference year. You're going to want to subtract that. So this means 4 years before 2010, essentially what that negative indicates. So here we have an association, right? Now, if you have studied advanced algebra, you would know this would be a rather quadratic kind of association, right? Or parabolic association, but it certainly is not linear. And notice that we can't just say it's negative because sometimes it goes up, right? So in this case, we would say this is neither positive nor negative. We would choose the neither choice. All right, so in this one, we have a table. The x is the explanatory variable, y is the response variable. We want to graph a scatter plot. Again, we could do that manually, or we could take it into StatCrunch, okay? The nice thing is when you do that, it brings the data over with it. And of course, if you remember, the variables are just x and y. So, and those were brought in for us as well. See? So here we're just going to go to graph, scatter plot, and that's it. All the other data, items should be okay. Let's say, oh, we didn't choose the variables. So for the x variable, we'll just use x. For the y variable, we use y. And that's it. Okay. So notice this goes from 4 to about 10. This in vertical, horizontally, we go to 17. So when you go back to pick your graph, you need to make sure you pick the one that looks just like that. So it looks like we're looking here. So you select it and then you are done. Okay. All right, so here's an interesting kind of problem. A teacher surveyed his algebra students about the favorite music genres. The students' responses are summarized in the bar graph below. And the student says there's a negative association between favorite music genres and frequency. What would you tell the student? And here is the graph, right? And of course, you would tell the student that these are what? These are categorical variables. This is a categorical variable. So you would never make a numerical analysis in that way, right? So basically you only make such kind of conclusions when you're dealing with numerical data. And a negative association can only exist between two numerical variables, right? So when a categorical variable is involved, don't ever make that kind of a statement, because remember, these associations are only between numerical variables. All right, so here's our last example for the day. We have a researcher who compares the breeds of dogs and their coat colors, right? Choose which of the following diagrams would basically be an appropriate way to represent that data, right? Notice that we're dealing with two categorical variables, right? So if you want to compare two categorical variables, you're basically going to be limited to these that we have seen before, two-way tables, and you can also use multiple bar graphs. These other ones you want to stay away from because they would not work for two categorical variables. All right, so study hard, do your homework, and stay safe until our next video.